Okay, everyone, today we're going to go over the review sheet. This is the first review sheet for the final exam, so we'll go through the problems that are on there. We might have to break it up into two videos. We'll see if we can get it all in one. So the first problem says find the vertex of the parabola. Remember, this is standard form, so we need to convert it into vertex form. To do that, we need to complete the square. So we're not actually solving for anything, but we are completing this square. We're using this part of it to complete the square. So we end up with y is equal to x squared plus 6x, and then I'm actually going to leave a space and put that minus 2 over here. And what I'm going to do then is I'm going to complete the square on this part. So I take half of that middle term, so half of 6, which is 3, and I square that. That gives me 9. But remember, because I need to maintain equality, because I'm adding 9 here, I need to subtract 9 over here. Okay, this is the square of a binomial. That leaves me with x plus 3 squared minus 11, and that puts us with a parabola with the vertex at -3, -11. Remember, we take the opposite sign of what's in here, and then that -11, we take the same sign. So this is, in practice, this is really the same as taking the parent function, y equals x squared, and shifting it 3 units to the left and 11 units down. Okay. When we're finding the maximum value, remember this is a parabola that opens down. We need to find the maximum, so we have to do -b over 2a first. So x equals -b over 2a. That would give you -5 over 2 times -1, so that would give you -5/2. And then you're just going to plug it back in to get what f of -5/2 is. And I'm not going to do that here on the video, but that does come out to be 15.25. Okay, so pretty straightforward there. Some practice with completing the square and talking about maximum minimums that may or may not come up as a word problem type situation. Okay, let's talk about the inverse of functions. Remember, graphically, when you're taking the inverse, you're reflecting over the line y equals x. And so to algebraically show the inverse of a function, all you're doing is switching your x and y and then solving for y. So if I rewrite this first one as y is equal to 2x cubed minus 5, then when I reflect it, I switch x and y, and I end up with x is equal to 2y cubed minus 5. And now all I need to do is solve that for y. So if I add 5 to both sides and divide by 2, so add 5 to both sides, then I'd end up with that equals 2y cubed. Then divide both sides by 2, I end up with that. And if I take the cube root of both sides, I end up with y is equal to the cube root of x plus 5 over 2. One thing I forgot to mention before, if you need to, go ahead and pause the video wherever you need to kind of look back over what you did. I know I'm talking kind of fast. It's just that I want to try and get everything into this one video, and I kind of have a time limit here when I'm doing this. So, okay, here, if I change that to y, and then I end up with y equals 4x, square root of 4x minus 9. If I switch my x and y, I end up with x is equal to 4y minus 9, the square root of that. So first thing I need to do is get rid of that square root, which means I'm going to square both sides of my equation. Whatever I did on one side, I have to do to the other. That leaves me with x squared is equal to 4y minus 9. So if I add 9 and divide by 4, I end up with x squared plus 9 over 4 as my inverse. This is just notation for inverse, so you can leave it like this, or you can write it as f inverse of x squared plus 9 over 4. This one probably looks to be a little bit trickier, and all of a sudden when people do problems like this, they forget their basic algebra skills. It's really all you need to solve this, right? If I set that equal to y and then switch my x's and y's, I end up with x is equal to 2y minus 5 over y plus 4. And so now I need to solve this for y. The first thing I'm going to do is multiply both sides by y plus 4. So I end up with x times y plus 4 is equal to 2y minus 5. I'm going to go ahead and distribute because remember I need to solve for y, so I need to isolate all the terms that have y's in them. And so now that I got rid of my parentheses, I can move all of my y terms over to one side of my equal sign. So I end up with xy minus 2y is equal to, and if I subtract 4x from both sides, negative 4x minus 5. Factor y out of there, you end up with y times x minus 2 is equal to negative 4x minus 5. And so y comes out to be negative 4x minus 5, all of that over x minus 2. Okay, so there's a little bit of review of finding inverses, quick little algebra review in there as well. So we did this back when we were talking about rational and polynomial functions. This is a rational inequality. And when we're dealing with a rational inequality, we first want to make sure we have everything expressed on one side of our inequality sign as a single fraction, which this one already is. Remember, we're looking for intercepts and asymptotes. So in order to find both of those, I need to set the numerator equal to 0, and I need to set the denominator equal to 0. So if I do that, x squared minus 5x plus 4 is equal to 0, so I end up with x minus 1 and x minus 4 equals 0, so x is equal to 1 and x is equal to 4. If I look at my denominator, if x squared minus 4 is equal to 0, which gives me x minus 2 and x plus 2. Oh, that's right, it's plus or minus 2. So those are my 4 critical values or critical numbers. Those are the numbers that I'm going to be putting on my number line. So I've got negative 2, the next number is 1, and then I have 2, and then I have 4. Clearly these aren't evenly spaced, which is totally fine. We're just using this as a guide to help us figure out where our solution is. From here then, what I need to do is I need to test values in these regions that test them back in this original fraction and see if they end up to be less than or equal to 0. So what I would do is I would put this entire expression into your calculator. So I would go to y equals and put it in. You have x squared minus 5x plus 4 divided by, and notice I'm putting the entire numerator in parentheses and the entire denominator into parentheses so that the calculator groups everything properly. Now, you can go to second table and then just scroll through the table. So you'll see when I'm less than negative 2, all of my numbers are positive. So I know that those are positive. When I'm between negative 2 and 1, notice I'm negative. Now look at negative 2, it says an error, right? I know that is in fact the case because remember that's coming from the denominator and that's where the denominator would be 0. So that's where I would have an asymptote. So I'm just going to draw in a dotted line there, and then it said from negative 2 to 1 that our answers were, or our solutions were negative. Now, notice here that I jump from 1 up to 2, and there's nothing in between. So you can handle this a couple of different ways. You can calculate it by hand, just pick some number between 1 and 2, which to me seems like it would be a lot of work. What I would do, I'd go back to my home screen. Because we stored the equation in y1, we can just recall it and plug in whatever number we want. So from here I would say vars, y vars, enter on function, enter on y1, because that's where our function is stored. And I'll pick a value, so 1.5 is between 1 and 2. And then you hit enter, and it tells you what it is. So that comes out to be positive. And you can go back to the table, or you can do it this way again. If I went to the table, you would see that when I'm above 2 here, I am, let's see, between 2 and 4, I'm negative, right? Because at 3, it's negative. So I know that. Now I also know that this is an asymptote. And I know these are zeros, so I know that those are actual values because it says less than or equal to 0. So I have to include those in my solution set. And so now that I have all of these different ones, I think above 4, let's go back to the calculator. Make sure we hit all of our regions. Above 4, then, we are also positive, so I know over here I'm also going to be positive. So I'm looking for all the intervals where my function is less than or equal to 0, where it's negative. So it's negative between here, which I have to put a parenthesis because I can't actually ever equal negative 2. Here I can put a square bracket because I actually can be equal to negative 1. So here and here, so this would be a parenthesis, and this would also be a square bracket. So this is my solution set. And when I write it, I would have parentheses negative 2 to 1, and then bracket, union, and then 2, 4, and bracket. And remember, I have to have parentheses next to the number that's an asymptote. Okay? If this was just less than 0, then these would also have to be parentheses instead of square brackets. The reason they're square brackets is because it says less than or equal to 0. Okay, the difference quotient. We did this a while ago. If you don't remember what the difference quotient is, hopefully this will come back to you. F of x plus h minus f of x, all of that over h. And so all you're doing is wherever you see an x, you're plugging in x plus h. So I first have x plus h squared minus 2 times x plus h plus 7 minus, now I can subtract my original function, x squared minus 2x plus 7. All of that over h. Notice that's in parentheses because it's minus the function. If you forget the parentheses, you're going to mess up your signs. If I expand this out, I end up with x squared plus 2xh plus h squared minus 2x minus 2h plus 7 minus x squared plus 2x minus 7. All of that over h. And now I can cancel out terms. So I have negative 2x and positive 2x, positive x squared, negative x squared, positive 7 and negative 7. And so my final answer then is 2xh plus h squared minus 2h over 7. You can factor an 8 over 7. Sorry guys, over h over h. I was looking at the 7. Here you can factor an h out of each of those terms, so you end up with 2x plus h minus 2 as your final answer. Okay, I'm going to wrap up this video there. We'll continue on with the rest of the problems in the next video. Thanks, folks.